electric field
Okay.
intensity.
Okay. So electric field intensity, basic problems we were doing. Okay, let's go ahead and let's try something else now. So yeah. Okay. So now we can try the derivation of electric field due to different shapes. And you tried this question in the last class, right? Are you able to solve this question or not?
Sir, I'm not able to do.
Sorry. You solved this question or not?
Sir, no, sir.
Okay. So then you can start with this question. You already know some of the basics of SHM. So have you tried this question or not tried?
Sir, I have not tried. So I need to try.
Okay. Okay. So try this question. This question is SHM combined with this electrostatics. So in SHM, how we find the period of oscillation? First of all, you also have to check that whether it is SHM or not. Yeah, tell me. Getting any idea?
Sir,
Yeah, tell me.
sir, I'm not getting, sir.
Not getting any idea. So, do you know that to find the time period of oscillation of the disk, what you will have to do? Like, first of all, do you know the process? So, if you will displace the disk little bit, it will go to this position, right? And at that time, this the force acting on the disk will be in this direction, right? Because this charge is negative charge. And when the force will be in this direction, now you can break it into component. You can take this component and you can take this component, right? Vertical. And then because of this component, there will be a torque about the point of contact. So that entire SHM concept here you have to apply angular SHM. So ultimately you have to prove that alpha is equal to omega square theta, or you can also do it by force method. You can go through this. See this here. This force is nothing but F sine theta, where this angle is theta. If you take this angle as theta here, this angle as theta, this component, and this is the force. This component of force will be nothing but F sine theta, horizontal component. And this F sine theta component is producing a torque about the point of contact. Why we are taking point of contact? Because there will be friction also. So if we take the torque about the point of contact, the torque due to friction will be zero. That's why. Otherwise, if we will take any other point, then torque due to friction will also come. So we are taking point of contact. About the point of contact, torque due to friction will be F sine theta into R, and that is equal to I alpha. From here, you will try to find the equation of F. Also, you know, or you can find the equation of alpha as a function of x, because for angular SHM, the what equation is alpha equal to minus omega square theta. Either you do this or you find the linear acceleration is equal to minus omega square x. You can express in any form. See, they have drawn this diagram. Look at this diagram. Look at this diagram. Look at finally what they have done. They have expressed the angular acceleration in this form. Angular acceleration is some minus omega square theta. And then from that you will get omega, and then 2 pi by omega is time period. This is the process for angular SH. To calculate alpha, what you will do? You will do this torque equation. Net torque will be equal to I alpha. I is not the center of the I is not the moment of inertia about the center of the disk, about the axis passing through point of contact. See this. You can ask your doubt.
Sir, no doubt, sir.
Understood? So you want me to go to next, or you want to write something? Okay, you have no doubt? So you want to go to next? Are you there?
It's like a country.
Yes, am I audible?
Say around with 70 countries.
Okay. A screen is visible or not?
The screen is visible, sir. No, no effects.
Visible.
Yes, sir. It is visible, sir.
Okay. So you understood this question?
Yes, sir. I understood.
Okay. So then we will go to the next. So let's go to the next. Okay, so can you find this? You have to find the electric field intensity at the center of a uniformly charged ring. Suppose this is a uniformly charged ring and the charge per unit length or linear charge density is lambda. This is lambda, which is given in the question. Lambda. Radius is r. You know the process, how to find the electric field, right? At an angle theta, you will go and you will take a very small strip of the string. Here you can see this length of the element, this length, will be nothing but r d theta. And then because of that a small element, there will be an electric field at the center, which will be in this direction. Electric field will be in this direction, dE electric field. And then this dE electric field will have two components, one component in this direction, one component in this direction. Are you getting it? This is nothing but dE, and this is the electric field due to this small part of the ring, this is a small part. So this we have at an angle theta, we have taken a very small strip which is subtending an angle d theta at the center. So length of this strip is simply r d theta. Are you getting it?
Yes, sir. I'm getting.
So then you will calculate dE, and then to find net electric field at this center, what you will do? See, one component will get cancelled, right? Check whether d sine theta gets cancelled or cos theta gets cancelled. So this will be d sine theta. From symmetry also you can say in which direction there will be net electric field. This is d sine theta. Calculate it. Write the expression of d and then you what you will do. Do it. If you have any doubt, you can ask. If you can do it, then we'll go to the next. You can just tell me the process and we can go to the next. So the net electric field at the center, and net will be simply the integration of dE sine theta, because cos theta components will cancel. So it will be simply integration dE sine theta. Simply dE sine theta. Right? Are you there? And then theta you will vary from theta equal to 0 to pi. You can do it,
Right.
right?
Yes, sir.
So if you understood, we can go to the next. Now you will just substitute dE value and integrate. That's it. See, this is the solution. You have any doubt, you can ask. Tell me, you want to ask any doubt or you understood? We can.
No doubt, sir.
You want to do it or you want to go to next? So this is the linear charge density lambda. So you want to go to next?
Yes, sir. Yes,
Okay.
sir.
Yeah. If this is the question, then what you will do?
So 0 to pi by 2 limit differentiation.
And which component you will integrate? Which
So
component? Yeah. Which component will get cancelled here?
the horizontal gets the vertical will
No, here both component will be there. So here you will have to integrate both.
it's
Are
an
you
x
seeing?
component and y.
X and Y both will be there. X is also there, Y is also there. Okay, in the same way, now you have to find the electric field intensity due to a charged ring on the axis of the ring. So in this derivation, again same process. On the ring, you will select a very small element, a very small part of the ring, and then because of this element, what will be the electric field at this point P? Okay, let's say D is the electric field. Then it will have two components here: D is sine theta, D cos theta, and D sine theta. Okay, and here which component you will integrate? So first of all, you will find the electric field due to the small
And the
element.
horizontal component we need to integrate. So vertical, I think it's
Yes.
that.
Vertical will get cancelled. So just integrate the horizontal. That's it. Cos theta you can substitute in terms of x and r. Are you getting? That's it. That is the whole process. See this. Also, you can see the final expression that is coming. This final expression, here you can see that what is value at x equal to 0. What is electric field at x equal to 0?
It will be a zero now, sir, because
It will be 0. And what will be the value at x equal to infinity?
at infinite also we can assume zero now, sir.
So if it is 0 at x equal to 0 and again 0 at x equal to infinity, means definitely at some point it will become maximum, because it is 0, so it is increasing from 0 becoming maximum, then again it has to come back to 0, right?
Yes, sir.
That's why there must be some maximum value. So now you can apply the concept of maxima. You can find the point where it will be maximum and then you can substitute and you will get the maximum value. Actually, if you will differentiate equator to 0, you will get that this will become maximum when x is equal to r by root 2. So at a distance r by root 2 from the center of the ring, electric field have maximum value. And then you will substitute in place of x r by 2 and then you will get the maximum electric field. You can ask your doubt here. You can check by differentiating this expression, equating it to 0, that you are getting r by root 2 or not. You will get it. Yeah, you can tell me. You can ask your doubts.
No doubt, sir. Understood, sir.
Okay. Understood?
Sir, understood, sir.
Okay. So you also know that in this expression, if you substitute that, if you take x as very, very small, if suppose x is very, very small as compared to r, means the point is very close to the axis, then you can find what will be the electric field. And if x is very large as compared to r, then also you can find the value of the electric field by using approximations. Here you can see that if x is very, very large as compared to r, then the whole ring will simply behave like a point charge. Because if there is a ring of some radius, and the electric field that you have to find is a very far away point. So for, you can see that this distance x is very, very large as compared to this small radius. So this whole ring you can take just as a particle and directly write down the electric field. Are you getting? Kq by x square. If you don't want to do this, then direct in this equation you can apply the formula, the approximation, that x is very, very less than r. For that you can take x square common in the denominator, and then you can convert it into a binomial. Are you getting? Can you convert this expression into a binomial expression and find the electric field for x very, very less than r? So this is very simple. I think no need to convert it into anything. If x is very, very less than r, then x square will be automatically very, very less than r, right? R square. So just simply remove this and you will get kqx by r cube. That will be the electric field. Kqx by r cube. See this, kqx by r cube for x very very less than r. Understood this? Are you there? You are listening? Am I audible?
You're audible, sir. I understood.
And if x is very very less than r, then this is the case. But what if x is very very large than r? Then what you will do? So then basically you have to ignore r here. And when you will ignore r, you will get kq by x square. In the denominator, r you can ignore now, and then you will get this form. Okay. So directly you can do here. Okay. So now you have to just go through whatever book you have, just go through these derivations of all the electric field. Okay. Here you can see that if you have a disk and you have to find the electric field due to a disk, then what you will do is you will take rings as the element. So first of all, you will take one element of radius r and thickness dr. This will be a strip. Here you can say a ring of radius r and thickness dr. And now because it is a ring, so because of the ring, directly you know the formula. Just now we derived. So that will be your dE here, because here ring is the element. And then you will integrate that dE. So the idea is same. Every time you choose an element, because of the element you find the electric field dE, and then you integrate within proper limit to get the total electric field. So here dE is directly you will use the formula of electric field due to a ring, because the element is a ring. See, this is the direct formula of electric field due to a ring, where this is nothing but Q charge on the ring, which is surface charge density into area of the ring, dq. K dqx by r square plus x square whole to the power 3 by 2. Here a small r is variable, x is fixed. Tell me.
Yes.
So finally, mathematics, this is the process, and then you have to integrate. So you just do these integrations from the book and see, are you able to do it? If you are not able to do any step, if you are not able to do, then you can ask doubts. But at the end, after derivation, you should also know this final expression for the electric field due to a disk along its axis. Because when question will come, you will use direct formula. You will not do derivation. But this derivation is also important. Jee Advanced, they can design the question in such a way that derivation is required. Again, in that final result for the disk, again same thing. If x is very greater than r, less than r, then these formula will get modified. Okay, that's it. You have to do. Okay. So these are different derivations are there. Electric field due to a uniform charged wire is there. So now there is a charged wire, a very long or maybe finite also. So here first case they have taken finite length wire. So it is a finite length wire, and at a point you have to find electric field. Again, same idea. You will take an element on the wire, you will find electric field because of that element, and then you will integrate. So try doing this from any standard book, and because in every case it is the same thing, and just you need to understand few basics of integration, and you will be able to do. If suppose it is a infinitely long wire, later you can see that we can derive all these expression in the next part of this chapter by using Gauss law, which is very easy. We will not do these derivations. We can with integration. We'll directly use Gauss law, and very simply we can find the electric field.
Yes.
So electric field due to an infinitely long charged wire at a perpendicular distance r is given by this formula: 2k lambda by r. The lambda is linear charge density. R is the perpendicular distance of the point where you have to find the electric field. Here you have to understand that this formula can be only used for infinitely long wire. See here, in case of finite wire, first thing you have to do is you drop a perpendicular from the point to the wire. And then you join the point with the ends of the wire. This you will do in case of finite wire. And then you see the angle made by this line with the perpendicular, theta 1, theta 2. And now you will go with respect to this perpendicular line at an any angle theta, and there you will choose an element of some dx length. It is at some distance x from here. Then because of this dx length, you will find the electric field here, which will be in this direction. Then you will take its component and you will integrate both the component. You will integrate both the component because both the component will be there. Because here the situation is not symmetrical. Theta 1 and theta 2, both angle are not theta. Are you getting? So parallel component will not get cancelled here because the point P is not exactly at the center, near the center of the wire. Are you getting? Not getting? And then again, same thing, you will find electric field because of that element, which is kq by distance square. And then again, you will integrate both the component. So first they have integrated the cos component, and again you will integrate the sine component. And then net electric field will be vector addition of these two, right? Mathematics. You need to do it. In this, you have any doubt, you can ask.
Sir, no doubt.
So these derivations you will have to do after the class. Then you will get the complete idea.
Thank you.